So what's the registry design pattern all about? Think of it like it's Batman's Batcave. It's your go-to spot to store your tools, all those handy objects or instances you want easy access to. Just like Batman can grab his grappling hook or Batmobile whenever he needs, the registry lets your code grab its tools on the fly. It's like a lookup table. You ask for an object and bam, it's there. Second, flexible and dynamic. Need to switch out an object? Just update it in the registry. It's like finally replacing Jar Jar Binks with literally anyone else. Third, it reduces boilerplate. Less repeated code. You don't want your code to look like the kitchen drawer full of random cables, do you? Alright, let's get real, no design pattern is perfect. The registry has its quirks. It has hidden dependencies. Imagine each component is a quiet introvert at a party secretly depending on each other through the registry. Sounds smooth until you're troubleshooting, and you realize it's like untangling a mess of silent code dependencies. Keep it simple. Too many components accessing too many things? You might need to rethink your architecture. Potential overuse. The registry is flexible but easy to overstuff. If it turns into a junk drawer, it's going to make debugging a nightmare. Only put in what's essential. Maybe even split things into smaller registries if it helps keep things clean. It is not ideal for large, distributed systems. For big distributed systems, a single registry could be a bottleneck. In larger systems, consider dependency injection or service locators. Or break down your registry across microservices if it fits. Alright, now let's bring this idea into the code. We will start with a simple logger class. This is just a straightforward way to log messages to the console. Here's our log method. In action, every time we call it, it will print our message with a log prefix. Nothing fancy yet, but it will get the job done. Now onto the actual registry. Next, we will create a registry class. This will act as our central storage, like the Batcave we mentioned earlier. We'll use a simple object to store items, mapping each instance to a key. See what we are doing? We've got a register method to add items and get method to retrieve them. Now, we've got a register method to add items and get method to retrieve them. Now every time we add an instance, we can give it a unique key, like sticking a label on each Bat gadget so Batman knows what's what. Let's put this to work with a logger example. Imagine we want all parts of our app to use the same logger instance. We'll register it under the key logger, and then later we can fetch it using the key. Now logger is safely stored in the registry. Any part of our app can access it. No need to create new instances every time. Here's where it gets cool. Let's pretend different parts of our app need to log messages, authentication, payment processing, you name it. Instead of spinning up a fresh logger each time, we just pull the one we registered earlier. And there you go. Auth logger and payment logger both refer to the same logger instance we registered. We're keeping it centralized, saving memory, and making sure our logs stay consistent across the app. Nice and clean, right? Instead of multiple loggers cluttering up memory, we have got one go-to instance that's easy to find and easy to use. And there you have it, fellas. The registry design pattern in action. Centralized, simple, and a lot less chaotic than a pile of random code. If this helped make your coding life a bit smoother, or just gave you a new trick for your toolkit, give the like button a tap. And if you're ready to be a full-fledged member of the Anti-Coding Coding Club, hit subscribe and officially join the club. Drop a comment with questions or even just your favorite coding meme. Till next time, keep the coffee hot and the code clean. Welcome to the club and a happy coding, fellas.